Bon, ahí estás. Salut mon cher,
Salut,
¿ça va?
¿cómo estás? Mira, ¿dónde estás aquí?
Bien, bien.
No te veo.
Pero yo sí te veo. Aquí estoy.
Bien, esto es una buena cosa, que tú me ves y yo no te veo, porque yo soy más guapo que tú.
¿Cómo estás?
Bien,
Bueno, ya va a comenzar esto.
cuando quieren.
This Advent seminar. And so we will broadly speak about our relationship to history and how we link it to our philosophical considerations. So first, Vincent Chinard will speak, then I, then Jorge Martinez Contreras, then Carlos Alvarez, and at the end, Marco Bamba. And so we'll speak about our relationship to history. So please, Vincent, maybe you should start. So first, Vincent Chinard will speak, then
Ay, ya no escucho nada, ya no escucho nada.
Espera un minuto, Marco, porfa, por favor.
Ahora está bien,
Gracias.
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 Perdonatemi, pero io non escucho nada. Io non escucho nada.
This one. Marco, do you hear us?
Yeah, now, ahora escucho.
Okay, great. So maybe the best way that Vincent, do you agree to start again?
Vincent, no problem. You can go ahead. I know what you say. Yeah, now, ahora escucho.
Entonces, este doble juicio se opone, por un lado, a la fe.
No problem. You can go ahead. I know what you say. Yeah.
Este doble juicio se opone. Se opone, por un lado, a la desvalorización de los argumentos históricos en la epistemología y por otro, a la sobrevalorización de los contextos sociológicos, dos concepciones adoptadas por opositores o escépticos de la desvalorización de los epistemología y por otro, la sobrevalorización de los contextos sociológicos, dos concepciones adoptadas por
Perdóname, si la presencia de Zoom es tan problemática, yo puedo simplemente no estar en la mesa redonda, usted continúa, no es un problema. No me voy seguramente a ofender. O si no, me dejan hablar, yo hablo 5 minutos, escuchan lo que tengo que decir y después usted continúa sinmigo.
On peut essayer?
No quiero que devienen.
Non, on va laisser un peu. for us
Yeah.
and open up for market. Thank you.
Pueden empezar a hablar.
A ver, trata.
¿Qué son dos concepciones adoptadas por los opositores o escépticos de la epistemología histórica? Por un lado, si el estudio de las teorías científicas no incluye o incluye muy poco su historia, corre el riesgo o incluso se condena a extraviarse y atrofiarse en el formalismo y el logicismo. Ahora bien, me parece que las herramientas y conceptos de la lógica o del formalismo matemático no son completamente adecuados para describir lo que ocurre en la elaboración y el uso de las teorías científicas. Por otro lado, las aportaciones de la sociología, aunque pueden describir los contextos en los que se elaboran las teorías, claramente, me parecen de menos interés para explicar la invención y la evolución de los conceptos científicos. Es evidente y se comprende bien por qué que las críticas dirigidas a la epistemología histórica son completamente distintas según lo vengan por un lado de los social studies y por otro del positivismo lógico. Los primeros denuncian la ausencia de argumentos sociológicos, los segundos denuncian la presencia abusiva de argumentos históricos. No entiendo cómo podría llevarse a cabo el estudio crítico de una teoría científica sin considerarla desde el punto de vista de su evolución y, por lo tanto, de su historia, que, en mi opinión, es constitutiva de la epistemología. Para negar esta necesidad, habría que sostener que es posible evaluar una teoría científica en un estado dado, remitiéndola a una especie de estado perfecto que hubiera resuelto el conjunto de los problemas y descubierto la verdad sobre las cuestiones a las que esa ciencia se enfrenta. Tal verdad y tal estado ideal nunca han existido ni existirán jamás. Existen nociones y conceptos indispensables para cualquier estudio relativo a las teorías científicas. Para encontrarlos, basta recorrer la literatura dedicada a la filosofía de la ciencia. Esta nos habla de principio, de ley, de anomalía, de verificación, refutación, equivalencia, experiencia, fenómeno, revolución, etcétera, etcétera. Estas nociones constituyen los instrumentos conceptuales sin los cuales sencillamente no es posible producir reflexión o escritos de naturaleza epistemológica. Ahora bien, ¿de dónde provienen? ¿Qué es lo que confiere sentido y una eventual eficacia? Precisamente la historia de las ciencias. Tomemos un ejemplo de todos estos conceptos fundamentales. Ponemos un ejemplo, y creo que cualquiera serviría. Es de la anomalía científica. Anomalía. Quizás sea posible crear una definición formal y axiomática de una anomalía científica. Sería tan artificial y tan engorrosa que tendría prácticamente nulas posibilidades de aplicación. Solo la inmensa diversidad de las situaciones históricas ha permitido forjar este concepto. Hay entre los conceptos que he mencionado uno solo que escape a este régimen. Hay alguno cuya naturaleza no sea histórica. Los datos sociológicos, económicos o ideológicos son evidentemente observables en el curso de las actividades científicas, claramente, y pueden resultar sumamente interesantes para el sociólogo y el historiador. Pero me parece que son casi estériles y vanos cuando se trata de comprender lo que sucede científicamente durante la elaboración de la teoría. Ser más o menos ricos, más o menos numeroso, más o menos solidario, más o menos libre, adepto de tal o cual ideología o religión, etc., no inspira los conceptos y nociones que constituyen la ciencia, salvo de manera más superficial y como comodidad. Las obras del estilo Social Studies son numerosas. Las hay malas y las hay buenas. Siempre he observado, es una observación personal, que aquello que hay de valioso en las segundas, buenas obras, no debe nada o casi nada a las informaciones y argumentos sociológicos. Libros como, y son ejemplos, es la administración de la prueba de Aten y Pest, o otro ejemplo, el Leviatán y la bomba de aire de Chapin y Sheffield, u tres ejemplos de buenos libros de social studies, El imperio del tiempo de Peter Garrison. Proclaman todos los dos el valor decisivo del enfoque sociológico para comprender el desarrollo de la actividad científica. El problema es que la causalidad de estas conexiones está ausente. Pueden establecer hechos sociales, económicos e ideológicos junto a las ideas y actividades científicas, pero deben conformarse con hacer pasar esa proximidad por una explicación. El método histórico es una condición de posibilidad de la epistemología. La sociología, yo creo que no. Las consideraciones sociológicas e institucionales en el estudio de las teorías científicas son no en sí mismas prejudiciales para el examen epistemológico, pero no son muy útiles para este, sobre todo cuando reivindican un papel mayor y necesario. El punto de vista presentado aquí no puede defenderse si se pretende aplicarlo a la noción de tecnología, de tecnociencia. En efecto, si se niega, se refuta la distinción esencial entre ciencia y técnica, se vuelve absurdo defender la inutilidad de los puntos de vista sociológicos, económicos o ideológicos para comprender estas últimas. Mi crítica a los social studies solo tiene sentido bajo la condición de insistir en la diferencia de naturaleza entre ciencia y técnica. En efecto, sería absurdo sostener lo mismo en lo relativo de la epistemología de la técnica, la cual creo, sin ser un problema, no puede prescindir de la sociología. Quiero que termine 2 minutos. Claro.
For my own, I will give general considerations about historical epistemology, but based on my own work about the history of the self-concept in biology. So for me, the ladder of historical epistemology is both rich and difficult to handle because it generally allows one to identify with a certain tradition, which is in fact quite diverse, but which broadly reflects a concern for the historicity of scientific knowledge within philosophical analysis. And it stands somewhere between rather an historical philosophy and an archived form of history that would reject any overly broad philosophical abstraction or generalization. Then historical epistemology seems to be very close to the Anglophone approach known as the integrated history and philosophy of science. For me, historical epistemology makes it possible to do two different things. First, it helps to develop a general reflection on the history of science and on the impact of history over scientific concepts. In this case, we find discussions about, for instance, whether the history of science is characterized by continuity or rupture, about the way a style of reasoning may shape scientific conceptual content, and about the relationship between contingency and necessity in scientific discovery. And secondly, I think that it helps to study the historical conditions under which particular forms of scientific knowledge are produced, validated, and transformed. This can be seen, for example, in Canguilhem's history of the concept of the reflex, or in Foucault's analysis of the historical constitutions of the human sciences. And actually, personally, it was a text by Canguilhem in The Knowledge of Life on the relationship between the Leibnizian monads and the concept of the cell that originally inspired my dissertation. Although the term monad was used in the early biology, this did not necessarily imply a conceptual connection with Leibniz's monad. But I tried to show that the Leibnizian monad was naturalized by different authors, such as the naturalist Charles Bonnet or the naturphilosophe Lorenz Oken. From a simple, partless substance reflecting the complexity of the world, the monad gradually became to designate a simple and observable entity of the living world. For instance, the physiologist Johannes Müller, who trained many of the major figures of the history of the cell theory, spoke of primitive monads to refer to embryonic cells and of secondary monads for the cells of multicellular organisms. So the biological notions of the monad thus operated within a double conceptual relationship. In relation to complexity, this simple living unit designated an intensive unity inheriting the spontaneous activity of Leibniz's monad. And in relation to composition, it was characterized by its capacity to combine with others in order to form a larger organic entity. So this double relation of composition and complexity can also be found in the construction of the concept of the self itself. The cell is the elementary level of biological organization, the basic building block, which then combined with others forms a multicellular organism. In this respect, it bears a compositional relationship to the organism. It is the part of the whole organism. But the cell is also an organized totality whose activity alone manifests the defining features of life. And in this sense, it also stands in a complex isomorphic relationship to the organisms. The cell works as a model of the organism because it reflects its complexity. It displays in the very most stripped down form possible biological phenomena that also hold for more complex organisms. And this is precisely the idea advanced by Jacques Monod and François Jacob. Everything that is true for bacteria are also true for the elephants. Then, historical epistemology continues to guide my work in two ways. First, the aim is to identify the different conceptual layers embedded within the contemporary concept of the cell and to make explicit the inherited theoretical assumptions that have structured its uses. The task then is to understand conceptual construction within their historical context, so as to retrace the argumentative path that justify scientific development in certain direction rather than others. Such an approach provides a critical reading of past scientific productions, and this critical perspective makes it possible to question to what extent this past conceptual formation may shed new lights on the conceptual achievements of the present. Therefore, secondly, these historical methods also help to revisit conceptual pasts that remained underdeveloped in their own time and to explore to what extent they might contribute to reframe the cell concept both in its contemporary uses and in its history. Let's quickly develop it. Over the course of the 19th century, beyond definitional pluralism, the concept of the cell consistently designated the fundamental unit of life. That is a physiologically autonomous organic unit possessing the characteristic properties of living beings. Then the cell embodied a form of biological atomism, according to which dividing the fundamental unit entails the loss of its intrinsic living properties. So, as a research program, the cell theory and these atomisms took a variety of forms, generated incompatible versions, and encountered a number of dead ends that became the target of criticisms. And by using historical case studies as a way of putting contemporary conceptual elaborations into perspective, it became possible to examine the different kinds of critiques directed at the cell theory as a theory that establishes the cell as the atom of life. For example, in the 19th century, the zoologist Adam Sedgwick argued that in certain animals, development does not proceed through an early segmentation into clearly distinct units. And in Sedgwick's account, cellularity appeared as a progressively constituted mode of organization, rather than as a unit given from the outset. And this reopens the question of the relationship between cellularity and organicity. While historical epistemology may invite us to revisit conceptual paths that remain underdeveloped in their own time, and thereby enrich contemporary reflection, it also calls on us to rethink the histories we tell about concepts themselves. In this regard, I recently read an article by Ariane Droscher, a researcher at the University of Florence, in which she challenges the classic analogy established in the history of the cell theory between the cell and this atom of life. And cell conceived so as interchangeable, independent, and isolable building blocks for living beings. And Droscher argues that this analogy was a rhetorical device employed by the opponents of cell theory rather than by its proponents, a kind of straw man used to discredit the theory. Yet this rhetoric is also deeply embedded in the historiography of the cell theory itself. So revisiting the aspects of history that were left at the margins in order to question the present time also requires a critical reading of the very history that has been written about the concept. More generally, and I will finish with this idea, I see historical epistemology as embodying a critical attitude. Canguilhem, for instance, promotes an identification of the values that shape the production of knowledge in biology. And this does not, it's not the idea that science would be arbitrary or subjective. It's more the idea that its very object, living processes, are normative. And to study life already involves categories such as function, errors, regulation, or adaptation, all of which carry an evaluative dimension. Scientific concepts in the life sciences therefore emerge within scientific historical context and not out of concrete practices. So historical epistemology reappears appears to me as a concern for the ways in which scientific concepts are historically situated. Each period reformulates scientific problems according to its own technical and intellectual frameworks. Likewise, Canguilhem insists that the life sciences are linked with the techniques that make them possible. Instruments, experimental methods, and medical practices do not merely apply to already constituted concepts, they actively contribute to producing them. So a new technique of visualization, measurement of experimentation modifies what can count as the relevance of a scientific object in the first place. Therefore, Historical epistemology is also a history of the intellectual, material, and technical conditions of knowledge. And from this perspective, the aim is to understand how certain notions become thinkable, justifiable, and scientifically productive within a given historical context. Thank you very much.
Well, good morning, everyone. In the history of science, the collapse of certain theories can imply a series of successive discoveries and proposals, as it was the case in the 16th century with Ptolemy's 1,000 years old geometry. Some of those imply the research of a single object or phenomena, in this case of an animal. The case is the pongo. For 3 centuries, an anthropoid that was very clearly described by a British sailor in the 16th century. And the orangutan was proposed as a pongo in the 18th century, but only it was in 1847 that the missionary obtained the cranium of that animal. This had a huge impact on Darwin's idea. This one was a kind of eureka discovery. I am not discussing of eureka discoveries. In the history of science, the collapse of certain theories had implied a series of successive discoveries and proposals, as it was the case, I already said that. In this presentation, we're interested in analyzing non-expected discoveries. Several major discoveries in history, rock art studies, have radically overturned earlier theories about human evolution, symbolism, religion, cognition, and artistic development. Far from being marginal corrections, these studies have forced anthropology, archaeology, and philosophy to abandon entirely all interpretive paradigms inherited from the 19th century and 20th centuries. We want to show how the description of painted caves and crafts had demolished previous ideas and created new scientific hypotheses that revolutionized the idea of prehistory and the nature of human mind. This is the case of Marcelo Sanz de Sautuola. These are the dates. He was a discoverer of Altamira Cave. La siguiente. No, la siguiente. Ahí está. Y ahora la siguiente, por favor. Unfortunately, to create a passage, the ceiling was then very low. They took away a lot of sediments, as it also happened in Lascaux and in many other caves several years after Altamira. La siguiente. Before Altamira, many European scholars, especially French ones, Martini, Gardaillac, believed that Paleolithic humans were intellectually incapable of sophisticated symbolic production. Humanity was imagined through a pseudo-evolutionist hierarchy in which primitive man lacked true beliefs, aesthetics, and abstract thought. When Sautola announced in 1918 a publication in Spanish, the discovery of highly sophisticated polychromatic visual paintings, his daughter in 1979, those scholars, especially French ones, rejected that as problems. They said that Sautola gave a painter to do this. The realism, perspective, shading, and technical mastery appear too advanced for Ice Age humans. In 1902, these scholars published a mea culpa, especially Gardaillac. Gardaillac, for you are not French, Gardaillac is a name typical of the Dordogne region of France, where many prehistoric discoveries have been made. So he published a paper. The reason is also French, because other painted caves have been discovered in France. The eventual identification of Altamira demolished several such Paleolithic humans possessed advanced symbolic intelligence based precisely on rock art. We think their mind was like ours, is what we think now. Art did not emerge gradually from crude beginnings. Aesthetic sophistication existed tens, maybe hundreds of thousands of years ago. The symbolic mind was much older than previously imagined. This discovery transformed social sciences and philosophy and reinforced simultaneously Darwin's evolutionary theory. Next one. The second case, very interesting, is the destruction of very important ideas of French paleoanthropologists as Henri Breuil and Leroy-Gourhan. Since they had also a succession, they proposed there was a simple, crude, naturalistic complex. And then Chauvet was discovered in 1994. It is 32,000 to 36,000 years old. It's among the oldest cave paintings in Europe. I said Europe. Yet the art was astonishingly sophisticated. They show dynamic motion, they show perspective, shading, overlapping figures, and there was also a narrative sequence. This destroyed the idea that artistic refinements developed slowly over millennia. Next one. This is the rhinoceros. When you see up, this rhinoceros moving their horn, like in modern stories. That's again. This horse are prototype. It was painted based on the first horse, the second from left to right. And as you can see, this is extraordinary painting. Next one. This is maybe a mythological redemption of a phenomena. Maybe this lion or lioness were the identification of humans. They are in chase. They're chasing bisons, and in certain ways you will see that horse also is playing a role there. Leroy-Gourhan has proposed that the very structural idea, men were identified with bisons and women by horses. And this is not taken into consideration anymore. This is yet before. And then is the end of the rock art started in Europe. This is a finding of Sulawesi, a peak in Sulawesi 50,000 years ago, and they have found more than 800. And in Blombos Folklore Cave in South Africa, we have this work, which is 77,000 years. So there is a lot of discoveries done. The last one. Thank you.
Well, thank you very much. I will come back to the problem of historical epistemology, but in this case, it's very related to my own development as a mathematician. And I will read it so to respect the small time we have. Already from my very first and somewhat serious contact with mathematics, I discovered that the explanation that I needed could only be obtained from the history of mathematics. My main concern, I should insist, was a mathematical problem, but it was the history of mathematics that allowed me to understand what I was dealing with from the purely mathematical point of view. I will not get into the details, but to summarize, the problem was related to the theory of covering spaces for topological spaces, particularly in the case of covering spaces of Lie groups. Maybe it was my advisor's fault, who taught me that the best way to understand the theory of Lie groups and their covering spaces was to read carefully Claude Chevalet's masterpiece, The Theory of Lie Groups. In that moment, I obtained a proof of what the isomorphism between the fundamental group I of X of a topological space X and the group of covering transformations in this space, defined as the group of homeomorphisms G of Y of the universal covering Y over the space X, which leave invariant every fiber of the element of the base space. The proof was correct, and it remains correct from the formal, informal, or logical standpoint, though I did not find there the explanation I was looking for, that which could help me to understand why these two groups were isomorphic. The issue at hand was related to the role of transformations groups, which later I found in another mathematical domain, the theory of permutations of the roots of algebraic equations and Galois groups, closely related to the theory of Galois and fundamental groups, and also to Galois theory, the theory of covering spaces and Riemann surfaces. This made me come back to the history of mathematics. I skipped the details of the works of Galois, Abel, and Cauchy, mainly in his Turing memoirs, and in a series of memoirs of the theory of algebraic equivalences, provide the key to understand what I wanted to understand. In fact, this theory of algebraic equations could replace the theory of imaginary quantities, according to Cauchy, and therefore could provide a completely new perspective to the theory of algebraic equations. All this, which connects with my first tips in mathematics with the work that is still in progress, I may say with my dear colleague Jean Dorn, allowed me to say that history of mathematics belongs to the essence and the very nature of mathematics. I am sure that the same conclusion may be obtained from other examples or cases. I will only mention two of them in an almost simultaneous and contemporary work, which on this axiomatization of geometry and arithmetic were made by David Hilbert and Giuseppe Perra. I do not have time to give a complete explanation of my point of view concerning these two topics, but it is worth mentioning that both have been widely discussed by philosophers of mathematics for a long time. Besides the obvious questions of what the exact purpose of their axiomatic approach for geometry and arithmetic is, only a partial answer has been provided for the question of which geometry or which arithmetic they are trying to axiomatize. I say that only a partial answer has been given, since it has been admitted that behind Hilbert's Grundlagen der Geometrie of 1899, it is Euclidean geometry and its axiomatization that is at stake. However, not many philosophers of mathematics have stated clearly who is Peano's interlocutor when he wrote his Arithmeticus Principia Nova Methodo Expositive of 1889, 10 years before Hilbert's work. I think that the axiomatic project of these two works, Hilbert's and Peano's, is understood when they are seen as being historically inspired, though no historical mention is provided by them. The historical inspiration, like the one I have mentioned for the relation between the fundamental theorem of algebra, the fundamental theorem of Galois theory, and the fundamental theory of algebraic topology. I say this for those who claim that the theorem, that this last theory, the algebraic topology, deals mainly with the classification of the homotopy groups. We think that Hilbert's main concern in the Grundlagen is to understand the role that the Pappus Peano theorem plays in proving the commutativity of the segment multiplication. Let's remember that this was originally defined by Descartes in his geometry. Hence, to clarify the role of that this projective theorem to provide a complete justification for the segment arithmetic. The relation or relative independence of projective geometry from the Euclidean geometry was what was widely discussed during the 19th century from Poncelet's masterwork up to von Schaut's Geometrie der Lage. Hence, the independence of two geometries that were born together, as we can conclude, reading carefully Pappus Book 7 of his mathematical collection, is what he was really at stake behind the search for independence of any axioms for an axiomatic framework or a mathematical theory. I think that in a similar way, Peano's main concern is mainly Euclidean and Diophantine arithmetic, but also it comes up to Fermat's conjectures on number theory, mainly Fermat's little theorem. Peano's main concern in his axiomatics is certainly to provide an axiomatic justification for the algorithm that supports Euclidean arithmetic and the great part for the Diophantine arithmetic, the antiphoretic algorithm. This algorithm required a complete justification for the arithmetic operation of addition and multiplication, but mainly for the division of numbers, division leading to a remainder which appears there not to measure a defect of this operation, but as a guide for the remainder class to which a natural number belongs when divided by another number. By understanding the main goal of this algorithm, I should conclude that sometimes the way in which the history of mathematical concepts is conceived provides not only the explanation we need to understand mathematics, but also provides new arguments to underline the Protean aspects of mathematics. Those consequences are that come from the antiphoretic algorithm for numbers support also the ring structure for polynomials and Cauchy's theory of algebraic equivalences. To close my brief comment, I could just finish by asking if all what I just said is somehow related to the historical epistemology of mathematics.
¿Tengo que hablar ahora? ¿Aló? Ya no escucho nada.
No, you can do it.
Okay, can I go? First of all, do you prefer speak English, Spanish, or French?
Yeah, you can do it in English, please, Marco. Yes, please do it in English.
English? Okay. Okay, thank you very much. It's a pleasure to be it's a pleasure not to be, it's a pleasure to be with you, but it's not a pleasure to be here where I am, because I would have preferred by far to be there with you, but life is sometimes difficult and require choices. So first point, I will overall speak about mathematics. A lot of what I will say, I think, also apply to other sciences, but not all what I will say apply to other sciences. I see Carlos doing strange. Do you understand? It's not good? You do not understand well?
Marco, can you wait a minute, please? Wait a minute, please.
But hello, so can I go? Can I continue or no? Hello, can I go?
No, Marco, please wait a minute.
Not understand well?
Marco, wait a minute, please.
No escucho.
Okay, Marco, can you try please?
Sí, puedo hablar. I can speak. That's better. Can I go?
You
Okay.
can, yes.
Should I begin from the very beginning? Okay,
From the
I go. I go. So if I understand well, English is the preferred language, so I go in English. And I say that it's a pleasure to be with you, but it's not a pleasure not to be there. That is to be here where I am. I would have preferred by far to be with you. So apparently still there is a problem. Carlos and Carmen and all of you, it's not necessary that I make my talk. I can leave you really. So I do not understand whether should I speak or not.
No, wait, Marco Sanchez, we have a little bit problem here.
Carlos. It seemed to me clear that the Zoom connection does not work. So let's stop, please. Does not make any sense to continue this way. Simply does not make any sense. It's for next time. I will come in Mexico in another occasion and I will tell you what I think. Okay? Bye-bye. Bye. Bye-bye. Bye-bye.
¿Te escuchaste? Sí. Ok, bueno, primero que nada, lamentamos mucho esta situación. Todo funcionaba muy bien hasta que surgió el problema de que todos escuchamos. ¿Sí? No parece fácil de resolver. Esperemos que se resuelva en el transcurso del día porque ya ustedes han visto en el programa hay muchas problemas. Estamos con el sonido. Se sigue escuchando esto, hay un eco, que apaguen el sonido ya. Hola. Bueno, hay un problema técnico, repito, todos escuchan, si yo no sé a qué se deba. Espero que se resuelva pronto, sobre todo porque tenemos planeadas, están programadas varias comunicaciones que se van a hacer en línea y pues, acabamos de constatar que por el momento la transmisión en línea tiene algunos problemas. Entonces, lo mejor, pues, lamentable, comprendo la ausencia de Marco, lamentable, por tanto, hay que tener una discusión más amplia, pero bueno, creo que debemos de continuar con la mesa redonda, ya todos los que estamos aquí expresamos nuestra posición respecto a la historia, la filosofía y la epistemología histórica, y pues creo que lo mejor es continuar tal y como estaba programado. Caroline es la dijo Dios Testamento, entonces de regreso comparto esto.
Well, maybe it's time to open a wide discussion with all of us. So maybe if someone has specific question, or we can keep it. Okay, please.
To Carlos maybe, and you say that you understand very well mathematics in a deep sense. You need to know the history of mathematics, I believe, yeah? But normally in the mathematicians don't study the mathematics, history of mathematics. Then what they are lacking, or should they study the history of mathematics? What is your opinion?
Well, let me say something that maybe was a little bit misunderstood. I am not saying that every mathematician should know history of mathematics in order to understand mathematics. What I tried to share was somehow my own personal experience. In the cases I showed, began when I proved in a memoir concerning what I said concerning covering space, regroups, etc. The explanation I needed, I found it was from history. It was only from that I discovered where did this problem came from. It's not necessary. I could not say this, that it is absolutely necessary to take this path for every mathematician. It was only the way in which I myself could understand what I was dealing with. That's my only point.
But you would say that studying history of mathematics would help to find new arguments from the past to understand better the rationale from that time?
Somehow, what I wanted to say is that history provided me not for the key for the mathematical proof that was needed, but for the origin, to understand the very origin of the problem that was behind. That's exactly what I wanted to say.
Are there other remarks?
Could I make more of you? When I have studied a little bit of the classical philosophy of science, sometimes inspired by the logical positivism, I have found that the ideas or the models that they have discovered to apply to empirical science are not applicable to mathematics. Do you think there is a different approach for mathematics? Should be a different approach to the study of the philosophy of mathematics, or it's the same? Exactly.
If I understand quite well, for me, I will give you a very simple answer. You will hear me. It's clearly yes, completely different. For me, the main concepts, the main norms to understand what is happening when mathematics is produced and when physics is produced, or biology, or I don't know. For me, it's really completely different, and for probably many reasons. But one, I just have is that the concept of the truth and the false exists, of course, if we are interested in what is happening with mathematics. Even in different styles we have. And it doesn't work when physical theory or biological theory is produced. It's not a question of this is true, this is false. No, it's completely wrong. So, and there is probably many other way that for me is clear. So that is that why our work for me starts with mathematization. I don't know if you remember, on always it's about mathematization. It means for me that mathematics is a science very special, you know, and that we try since maybe 15 years to work about how mathematics are involved. It's different way to be for the mathematics to be involved in. Just to finish about that is for the reason why personally I work very much. I don't know if I work very well about the impossibility of the concept of physical mathematics. For me, it doesn't exist. It's physics, it's maths, it's relation of property.
Very briefly, I agree totally with the need for a history. But I think there's a very important epistemological difference when you are doing formal sciences and empirical sciences. I don't know, but I suppose the P number is the same in more possible words. Whereas in biology, we discover things that no one expected. For instance, the platypus, the orbital. So I agree totally with the idea of history, but I'm very much interested in empirical discoveries. Unfortunately for me, I'm studying a science that started in the 19th century. Whereas you mathematicians, you study a very, very old science. I don't know if you know that in Glasgow, they have geometric forms. But that's me, I don't know. Thank you very much.
Jean, Anne.
Thank you. I would like just to ask a question. Using what you have shown us about proto-historic art. And it's just an anecdote concerning drawings, let's say, on stones. And there, you have a very surprising thing is you have two kinds of, in French it is called on biface. I don't know the word, those stones that are two sides, mainly two sides. One is curved and the other is sort of a plane. Then the theory was a sort of Cartesian theory using its mathematics. It's clear that when there is a circle and you put point at the center of the circle, the man, woman who did the drawing knew he was doing something which is not something you find in nature. Okay, so the Cartesian theory was to say clearly the first knowledge, how to express it, the first knowledge of forms, let's call it geometric forms, was the plane one, because space geometry comes afterwards. Now, with all the documents we have, we know that in fact, the two civilizations are completely distant. There are places where the forms in space geometry came first, and there are places where the plane geometry came first. So what I say that history provides problems, provides problems on our ways of understanding how things progress is not a good word, how things are created. And I think that when Carlos was speaking, I perfectly agree about in order to use better understand, and so even mathematical creations of recent past, V groups and so on. For example, it is interesting to ask questions of what is the art of creation there. And I think therefore, even if you look at creations in biology, I mean, then it seems to me that with history, you better select questions which are not very straight, very positive answers, but questions. What is space geometry? What is plane geometry? That's the example I did. So I think this also explains perhaps our interest into history as an understanding of even actual domains, even in biology or in mathematics, and I don't see too many differences there. So, using what you said.
Well, thank you for your thoughts. This is for all of you, and I sort of agree with most of what you said, but somehow it becomes like a moral necessity, do you think, to be aware of the context? Somehow you're saying, some of you are saying how useful it was for you to get in touch with the history and with the development of science and with the context. I can also see the dangers of going too far and saying that all depends on the sociology, which I agree it doesn't. But what would be your advice for, say, young people or for colleagues who have a mathematical practice, but somehow are not very aware of the history of the or the consequence of what they do?
Maybe define every month for both of you regarding this.
Well, no, I didn't understand completely, so because that I'm embarrassed.
Well, I would say I didn't understand clearly what you meant when you said that it was somehow a kind of used moral invitation. I insist and I would almost repeat what I answered first to Max. When we first agreed to speak in this round table, because we all know each other for many years, we all agreed that somehow we will say something about our own particular personal development and how philosophy and history of sciences came into our lives. But there's no moral invitation, I think. There wasn't, and that was personally trying to explain how I understood mathematics. I would not say that it is the only way to understand mathematics. I did not say that everybody should know history of mathematics in order to understand mathematics. It is just the way my personal experience, how I understood, and I still understand mathematics. That was all.
Maybe about, I hope something about your question. Probably I will be extremely too radical, but for me, I'm not very interested in support moral aims or in science. And what science useful or not? I don't say that it doesn't exist. Of course, if I change my cap, I am very aware about that. But about epistemology, which is try to understand what and how happens something produce scientific theory. I think that the moral or use or utility or application of science has a very, very small role. I think that so that is the only the motor dynamic why we are interested, or maybe the scientific are really interested in the curiosity. It's curiosity. Curiosity to produce, to discuss, to try to understand something better about the relation between us, human, and nature. That is curiosity. And that works for math, for biology, for physics, for everything. That is all. Yeah, I think it's only. I don't know if it's about your question.
A very short answer can discuss afterwards. And the thing is, everything is anthropomorphism. Hume has shown all geometric forms are abstractions from real things. I think the question is the difference between the history of technology, which was already well known in the 19th century. All the names of technology are from the Dordogne region. And art, it is astonishing in art how we show everything suddenly. But maybe we can discuss that later on. Thank you very much.
Well, I think we should close this first panel right now, not that late. Well, thank you very much, and we hope to have a nice advanced seminar after that. Can I get your attention for 1 second?
there. And for me, a pleasure to do. Te doy la palabra.
Thank you. I'd like to thank you for this wonderful opportunity and for organizing this conference. I am a first-year PhD student working under the supervision of a philosopher of science, SUHFECIM-UNAM, at the HPSC lab, and a biologist, Eric Battest, Sorbonne University, in a bioinformatics lab. My presentation pertains to the philosophy of biology and proposes a contemporary reflection on science in the making, focused precisely on the evolution of the concept of age in its various modalities, possible, necessary, in relation to the concept of aging, and more particularly, to various evolutionary and physiological theories of aging. There is a particular interest as a philosopher in questioning the concept of age, since the theories underlying the process in question, aging, lack consensus, such that within science itself, aging as a studied object sometimes seems to lose consistency. There is only consensus on the heterogeneous nature of aging and probably also on the need to propose multiple measures of its progression. In this context, my hypothesis is that social and environmental factors must be taken into account to better understand and measure aging. This raises differently the conceptual question of what age is and invites scientific, epistemic, and philosophical inquiry into what it is. Philosophy can thus contribute to a task that biologists have already begun, including interdisciplinary work between biology, sociology, and philosophy of science. I am talking here about the current state of contemporary science, and I will try today to evaluate the epistemic and practical benefits of a possible and future change in the concept of age, in particular of a presumed biological age. I want to sketch out this possible change, both in its conceptual and theoretical dimensions, by better considering the social and environmental dimension of the progression of aging. In particular, this is the reason why I'd like to talk to you about the development of the concept of a properly biosocial age, which is actually the subject of my thesis. So it is something I have not yet fully developed, as I had only started a few months earlier. But I want to show you its interest by making the conditions of this biosocial age more explicit by asking some of the main questions. Why and when does a concept theoretically cease to be useful? Can we identify a single concept of age across its transformations? And how environmental, biological, and sociological factors can explain the changes of the concept of age? We can begin with the starting point. What accounts for the age of our body, namely what biologists call physiological age? This requires proposing a reflection on aging as such. We can start by returning to the biology of aging, its theories, and the definition of aging, with the aim of first presenting how the concept of aging has become problematic in its theoretical and scientific context. We will see how this impacts the concept of age, and in particular, the idea that there is a biological age. There are many theories of aging, notably evolutionary ones. The intensity of selection decreases after some times because after some point, in a large population of individuals, Most of them will be accidentally dead. The competitions will be less intense. Hence, the selection will decrease in intensity. Most of the deleterious genes whose effects are expressed after this point will not be filtered out by selection. Most of the evolutionary accounts of aging since 1950s rely on this idea. There are also proximal theories of aging, as illustrated in particular by work on cellular and subcellular hallmarks of aging, for example, telomere shortening or the accumulation of senescent cells, and controversies exist to determine whether a theory is proximal or ultimate. And regarding ultimate causes of aging, according to the partition of Ernst Mayr between ultimate and proximal causes in biology, evolutionary theories dispute the causal role of natural selection, despite a certain consensus on the shadow selection, so that aging is sometimes considered to be selected for, sometimes a byproduct of selection, and sometimes not selected. Depending on that, on the proximal side, we argue about the programmed or non-programmed nature of aging or quasi-programmed. In other words, about if aging is governed or not by genetic instruction. More generally, this is clearly a highly theoretical, contentious issue. One might therefore ask, according to these different understandings of aging and the disputes arising from these differences, are they real different concepts of aging? And how should we understand the concept of aging? One could therefore adopt an epistemological pluralism and argue that there is a multifactorial concept of aging which takes together different theories of aging. However, one might consider another response given by Alan Cohen and colleagues through an evaluation of these disagreements, which should suggest that given this specific theoretical situation, the content of the concept of aging is not sufficiently unified to justify it as a single concept. It means that these controversies about aging arise because the phenomenon behind the concept does not exist in a unified form. This means that the term aging is incorrect. We can cite a second paper, also written by Alan Cohen and several leading aging biologists in 2020, arising from this epistemologically problematic context, published in a biological review called Mechanisms of Aging and Development. They suggest properly ontological and philosophical consequences of the questionment on the actual change of the concept of aging, and they suggest stopping referring to some phenomena by the name aging in a scientific context. Here is the radical thesis of this recent paper. There is no such a thing as aging. Here are also some reasons. In particular, there is no single causal process, and epistemologically, there is no single theory. This leads to what we can call a scientific abandonment of the concept because of the phenomenon. The goal of the paper is to advance the theories themselves by reconfiguring concepts. The consequences that follow are that scientists seem to allow us to adjudicate on the use and relevance of a concept for theoretical reasons. In this paper, they drew logical diagrams showing the correspondence between the linguistic categories defined by the ellipses and reality represented by the dots. This is to see whether the concepts and objects corresponded. Here, aging fits into diagram A. It means that phenomena are, in fact, underdetermined by the concept of aging. This means that in reality, we rather need context-specific definitions for this phenomena more than a single definition or a single concept of aging. From this case study and this radical choice of conceptual abandonment, we may want to look at what this will mean for the prospects of the concept of age, which is the object of my thesis. Indeed, age is linked to aging.
but age is not aging. So the relationship between these two concepts still needs to be clarified. What insights can we gain into the evolution of the concept of age based on an example of the abandonment of the concept of aging? A distinctive feature of the concept of age is that it is linked to measurement. For this reason, this concept does not refer to a process, but to a measure. The concept of age is more malleable in the sense that it depends on what one wishes to measure, in this case, aging, unlike the concept of aging, which refers to a process, an ontological one. Therefore, we may wish to interrogate its current evolution in relation to an epistemological investigation of measurement, by thinking that there is probably not a single measure of aging. The goal is to examine the various terms underlying this concept. This involves a conceptual analysis of age, which is missing today, to understand how we do age. To explain this concept, we actually need to discuss several terms and adjectives: chronological age, biological age, and biosocial age. These terms actually refer to different things and different understandings of aging. First, we have chronological age, which is the time elapsed since birth, measured in years, and which is the same for everyone. At first glance, it doesn't seem to pose any particular problem. Then, biological age, which is more difficult to measure and to know what it is really about. Researchers have found to predict people's chronological age using clocks and also biological age, which corresponds to the gap between the predicted chronological age and the real chronological age of an individual. This can be written simply as follows. ACP is the predicted chronological age, and ACR is the actual chronological age of the individual. And biological age is the delta age, that is the gap between ACP and ACR. And if delta age is greater than 0, then we can see that aging is accelerated and vice versa. Researchers are looking for a biological age because the measure of chronological age does not take account of the heterogeneity between individuals aging. But is it really the case with biological age, as it is explicitly suggested, which is based on chronological age? The question of how to interpret the difference between chronological and biological ages remains unresolved. In particular, the question of the relation between aging and these measurements has not been definitely answered. We could go into a little more detail about biological age, as it is measured by different prolific biological clocks based on different processes, epigenetic, transcriptomic, proteomic. There are only various specific biological ages, such as epigenetic age and transcriptomic age. In fact, different clocks of biological age do not measure the same thing, since all that ones published in 2013. Sometimes they measure the time remaining before death, and sometimes the rate of aging, and so on. And each biological clock relates to one or plural parts of the body, but not to the body as a whole, meaning that the body can only have several biological ages. Moreover, clocks are only based on age-related or correlated process. It seems consequently insufficient to say that biological age is a measure of the progression of aging. And for these reasons, we do not have a clear understanding of the concept of biological age as we do of chronological age. At this stage, we can make a short detour on the transition from chronological age to biological age in order to clarify what biological age is relative to the first concept of age. The relationship is not self-evident. First, one might ask whether we can identify a single concept of age across this transformation. People have indeed different chronological ages only because they were born at different times. But have people different biological ages because they aged differently? At this stage, the concept of biological age and its measurement seems to be incomplete. Therefore, the idea is to consider these two concepts of age in relation to a new, as yet unexplored concept to clarify the concept of age in general, the concept of biosocial age, which should take into account the social environmental conditions in which a person ages. This work takes a different turn from the choice of abandoning the concept of aging in a problematic epistemic and ontological context. Here, the desire to propose a new concept, biosocial age, enables us to take a second look at other concepts of biological and chronological age and their measures. The concept of biosocial age is precisely linked to other concepts that seem insufficient. In particular, it must take its grounding in the possible limits of the concepts of age regarding aging measurement. In particular, due to the heterogeneity of aging, both between individuals and within an individual. The idea is to reflect methodologically in this presentation on the place of a new concept in relation to concepts already in place, and what this means concerning the measure of aging, without yet fully knowing what this concept will be. One might present what theoretically supports a conceptual change of age with respect to aging, and the scientific objectives behind this project. The theoretical dimension, which is parallel to the biosocial, consists in the necessity of including environmental and social in theories of aging, in particular of broadening evolutionary and physiological theories. This conceptual inclusion may entail a reconfiguration of theories and possibly their unification. This justifies at least a reconsideration of the concept of biological age, which we will outline here because of the biosocial nature of aging. Is biosocial age a more useful or only more explanatory concept than biological age to measure the progression of aging? What developments to biological age are possible and desirable in this epistemological context? One might choose biosocial age because of the context-dependent nature of aging, which is crucial for its measurement and is not really taken into account by other concepts of age. Here, the term biosocial refers to the social dimension in the broadest sense, that is to say, everything that surrounds the organism and is referred to as the exposome. For example, air pollution, viruses, depression, which are considered to be age-distorting, and that we can therefore refer to them as age-distorters. To give a first definition of the concept of biosocial age, we can settle for an operational one. It consists in the result of taking into account in the measurement the part of the context in which an individual ages, since social environmental causes of aging and age-related diseases are at work. The idea is to obtain a more global measure of age than biological age, and we have to think what this means conceptually. This is why we are searching for an integrative concept such as biosocial or biopsychosocial age. The aim of this concept is to support scientific work on measurement. It gives the concept a properly heuristic value. But how can we develop this concept? In other words, how can we further establish the concept of age? How can we develop it in relation to the concept of biological age? There are indeed many difficulties in changing concepts and also in changing theories and models. It is a joint effort between philosophical work and biological work on aging theories and measurements. one might present some general logical possibilities about a transition between two concepts. Here are some elements on this question. Must the concept of biological age survive if there is the concept of biosocial age? Here are some introductory epistemological conditions: substitution, coexistence, identity, and subordination. One might look further about two possibilities. The aim of biosocial age could be to propose a more inclusive concept. This could fit with the hypothesis of substitution of biological age by biosocial age. But one can also consider that it rather accompanies the concept of biological age without supplanting it. Biosocial age could be a new concept to describe something that is missing from biological age. In this case, one can speak about coexistence between concepts. That means that we keep the concept of biological age, but we understand it better and differently through the concept of biosocial age, because they both describe different parts of the progression of aging. We can sketch an example of a draft biosocial measure of age related to this new concept of age, which is different from a strictly biological measure. It consists in replacing a single biological aging trajectory, which we can call a metaphysical one, with plural trajectories of aging. Because of the existence of age disorders, who are, for instance, viruses, air pollution, and everything that forms part of the exposome. People do not age in isolation, and this therefore influences these possibilities of aging, which may be incommensurable or difficult to compare. This is about the construction of both a new concept and new social environmental theoretical models for measuring aging. Finally, what are the scientific factors driving this conceptual development? It is, in particular, a theoretical gain in precision, notably in practice for measurements. It helps to think together and reconfigure elements in aging process. It invites us to construct a more global measure of aging. For instance, by integrating extra genetic data in biological analysis, which is a part of my thesis projects, to explain and measure this trajectory. It is also an ontological gain. This really questions what an aging individual is. We are trying to understand the implications of the fact that aging does not occur abstractly. Seeking to explain aging simply by looking at the individual would amount to miss what needs to be explained. We see here the explanation value and also the philosophical value of both a concept and a measure. This helps us to understand better that living beings, as they get older, are not monads in an ontological sense. Thank you very much for your attention.
Okay, thank you very much, Juliette. We have some minutes for questions.
Thank you. easier for me to speak French, so maybe. Okay. For answer to the first question, maybe the link, there is a direct link with the theory of the programmed nature of development. And so if development is programmed, we can, there is the question, ouais, en français, le genre. D'accord. Ma réponse, elle sera rapide. Oui. Ah oui. À la première question, je ne suis pas sûre, mais je pense que c'est un lien direct du fait que l'idée que le vieillissement serait programmé se fonde sur l'idée que le développement d'un organisme obéit à un programme génétique. Et donc, c'est en ça que ça rejoint la controverse actuelle de savoir si le vieillissement est ou non programmé. Et donc, en ça, c'est complètement lié. Et pour répondre à la deuxième question, bien, c'est précisément la difficulté à laquelle j'essaie de me confronter dans ma thèse et sur les conditions épistémologiques d'une mesure qui inclut les contextes dans lesquels les individus vieillissent. Et l'idée, c'est d'établir un peu des contextes environnementaux qui sont plus à risque que d'autres dans le fait qu'un individu va vieillir avec des maladies, va vieillir donc plus vite qu'un autre individu. Mais j'ai pas la réponse à cette question. Mais je ne vois pas, par contre, pourquoi on ne pourrait pas essayer de mesurer cette part-là. Et parce qu'elle a des effets. Donc pourquoi ne pas vouloir essayer justement de quantifier, même si c'est peut-être pas la bonne façon c'est peut-être pas exactement le bon mot, mais pourquoi ne pas essayer d'établir des différences et de comparer en fait l'effet de certains contextes par rapport à d'autres sur des individus. I may understand not more when you say that maybe kind of approach according for temporalizing some social questions. But maybe we also consider the opposite. I mean, considering the social context within meteorology. I mean, in a sense, the way medicine works is like curing a lot. But we consider that prevention is better than curing. So maybe if we can feel socially the effect of age and disease, maybe it would be a bit of a risk for considering politics about medicine and I totally agree with you.
Because we have, so we go to the next communication. Bye. Thank you very much.
Well, good morning, everyone. It's an honor for me to be here in this seminar, and I'm going to be presenting you today the modal moral coevolution hypothesis and morals and adaptation guides the evolutionary epistemology modality. I know this is a long title, but so I will break it down. First, modal epistemology is about how we come to know modal truths, whether something is possible, contingent, or necessary. And over the last 3 decades, numerous accounts have appeared across the rationalist empiricist spectrum. However, only a few proposals have considered what evolution theory might say about the cognitive process by which we form our model beliefs. Some accounts with evolutionary insights include Nozick's evolutionary skepticism, Williamson's counterfactual-based account, dispositional affordances-based account, and modal normativism. After briefly reviewing this, I'm going to argue for a new account, the modal moral coevolution hypothesis, modal notions about how the world can and must be, and deontic notions about what we are allowed or ought to do, share a common origin. They had similar belief-forming mechanisms and only became partially independent late in evolution. This is a work in progress in my PhD research. However, the core idea is that if modal and moral notions are close one to another, they may have evolved in some species, especially primates and humans. If the hypothesis is correct or even just plausible, then the evolutionary studies of modality may shed light on the evolutionary study of modality. Robert Nozick was the first philosopher to apply evolutionary insights to modal epistemology. He believed that there are no interesting and important metaphysical necessities, and that we do not appear to have such a faculty to assess the truth of moral judgments, since it is implausible that the evolutionary processes would instill that within us. Thus, we might say modal faculty would be basically a waste of valuable cognitive resources. However, the last statement has motivated the reliability challenge. If we're able to justify and believe in model statements, we must have a reliable faculty or set of faculties working together for forming beliefs of that sort, the existence of which is best explained by evolutionary theory. So no ad hoc modality detecting faculty is allowed for explaining model knowledge. Now, Nozick believed that an evolutionary interpretation of his true tracking theory might explain why we find certain theories more intuitive. Individuals who could recognize a structural relation, given a factual connection, were more fit and were selected. And this might explain why, for example, geometry feels intuitive. Our ancestors succeeded evolutionary by using it in daily reasoning. However, Nozick noted, something seeming self-evidently true does not guarantee that it was ever strictly true. And it is well known that the Euclidean geometry does not match physical space. Thus, I quote, we might make a similar claim about the self-evidence of deductive rules and the principle of logic themselves. One need not to invoke their necessity. It might be true, it might be enough that they are true, even if only contingently, or just even true enough, and then they have held true for long enough to leave an imprint upon our evolutionary endowment. Thus, the strength and depth of our intuitions about the statements cannot be used as a powerful evidence for their necessity. Intuition is an extremely frail real upon which to build a philosophy. So intuitions shaped by evolution are not reliable for achieving model knowledge. Furthermore, Nozick invites us to examine a statement that was considered metaphysical or physical necessities, such as every event has a cause, and to observe how their status has changed with scientific advances, such as quantum mechanics. So the moral of the story, there is no guarantee that our present intuitions about necessity will stand the test of time. Moving on to another evolutionary perspective, Timothy Williamson argues that the ordinary cognitive capacity to handle counterfactual conditionals carry with it the cognitive capacity to handle metaphysical modality. In this account, there is a bridge between counterfactual logic and model logic established through certain action, and this yield logical equivalence between model operators and counterfactual conditionals. For example, P must hold just if it will not fail without absurdity, or P must hold just if even if it failed, it would hold. If we allow quantification of a proposition, such as equivalence emerges, and P must hold if it will hold whatever held. Thus, model thinking may emerge as a byproduct of counterfactual reasoning. And what does evolution has to do with this? Well, first, the counterfactual-based account is a non-extraordinary approach to modality. Indeed, it addresses the reliability challenge well. And second, we can see counterfactual reasoning as an adaptation that enables us to learn from our previous mistakes and thereby improving our agency in similar situations to those that motivated the what-if scenario and to explore non-actual possibilities. Third, evolution explains both adaptations and their byproducts. For example, the capacity to state and evaluate the useful counterfactual. If he had been quiet, he would have escaped the bear, might also enable us to state and evaluate an uninteresting model proposition, such as it is necessary that a bachelor is an unmarried man. Finally, counterfactual conditionals behave like conditional probabilities. For example, both are non-monotonic, but counterfactuals are easy to handle. Thus, the counterfactual-based approach is quite promising from an evolutionary perspective. Another evolutionary account in model epistemology concerns the dispositions, the tendency of an object or system to act or react in characteristic ways in certain situations, and affordances, which are whatever the environment offers the animal, what it provides either for good or ill. Now, there is no unified account of these concepts, since many disagree on how to formulate them, how successful they are. However, some philosophers and psychologists think that animals recognize relevant possibilities in their environments through the knowledge of dispositions and affordances. Thus, this framework can account for the use of tools and niche construction. In line with this framework, Barbara Berder has further developed the agency-based model epistemology, according to which the roots of our model thought and knowledge are located in our experience of our own agency. By being agents in this world, we possess a wealth of model knowledge. This view disputes skepticism by asserting that model knowledge is accessible through everyday interaction with dispositions and affordances. Finally, let us consider model normativism, mainly championed by Amy Thomason. According to this, basic metaphysical model claims do not track or describe special model features of the world or other possible worlds. Hence, the previous view might misunderstand modality, except possibly for Berder's agents-based account. Instead, model language serves the function of mandating, conveying, or renegotiating rules or norms in particular adventurous way. And while this view is fairly new, it has important antecedents in analytic philosophy. For example, Gilbert Ryle believed that a scientific law is like an inference ticket, which leads its possessor to move from asserting factual statements to asserting other factual statements. Thomason's invite us to think about the rules in a game such as chess. Rules can be given in the indicative or imperative mode, yet modal verbs explicitly establish the status of a norm. For example, a bishop in a dark square must move on dark squares, indicates a non-negotiable norm and limits the player's action. Furthermore, some rules can only be instated by using modal verbs, as in, does a player must do a move in each turn? No, a player may skip her turn. In this sense, modal verbs work like deontic operators for obligation and permission, and a similar case applies to semantic rules. Modal notions allow us to mandate, convey, and renegotiate these rules. If we have a semantic rule, say bachelors apply only to unmarried man and not to unmarried woman, we are entitled to add a modal operator if it's necessary that a bachelor is an unmarried man. Now, what does evolution have to say? Well, Thomason argues that mastering semantic rules which ground modal notions might have been selected for the advantages it provided to individuals in a community with a common language, since it is undoubtedly useful for its members to have the capacity of mastering the rules and to have some way of instructing in these rules of use, communicating the rules of use and policing misuses. Nonetheless, for the language of the community to be responsive to our changing circumstances and interests, a key feature for a moving species like ours, there also must be ways of pressing for innovations of various kinds, renegotiating the rules of use. So having metaphysical model language enables the speakers to do all these things. Rather than arguing for a special model faculty to evaluate model truths accurately, modal normativisms argue for an account of why we modelize as well as we do, and the answer may lie in our plastic ability to master semantic rules. Now, let us set the ground for the coevolution hypothesis. As we have seen with modal normativisms, modal verbs do have a double use. They will function both in alectic and deontic contexts, and this feature is not exclusive to English. This can be found in Spanish, French, German, and more notoriously in Indian, where depending on the context, the generic stative modal verb fiat can be translated as could, would, should, both in alectic and deontic way. And this is something overwhelming. Given this constant across different languages, Chakrabarty and Nikolai encouraged some questions. So what if the deontic modality were treated as primary and alectic modality as derivative? And how would our philosophy, including epistemology and modality, have to be revised to accommodate the theory of what is possible and necessary within the theory of what is permissible and obligatory? The thesis that the deontic modality is the primary one is quite unorthodox, and I don't think that it's a good path to follow. However, I think it's worth asking how alectic and deontic modality may interact. We are now in position to state the modal moral coevolution hypothesis. Given the closeness between alectic and deontic modality and the fact that the latter has been subject to evolutionary pressures, we might suspect that they share a common origin and have similar underlying mechanisms for forming beliefs, and became somewhat independent only in a later stage of evolution. I will argue for this hypothesis, showing that one, it works better than the rival hypothesis that the ontic or alectic modality is single evolved, and two, that it has explanatory potential for translating the evolutionary studies of morality into evolutionary studies of modality. Against simple evolution theory of modality, we might say that evolved traits do not come alone. An old objection to Darwin's theory of natural selection is that if organisms were to change, then the organism's constitution for the viability will be compromised. A perfect organ like the human heart cannot embrace changes. Darwin replied to this by saying that first, it is only after a long period that great changes happen, and second, that changes, variations, do not come alone, but in clusters. For a heart to change, the circulatory systems and muscles may also have to change. Now, moral behavior is a complex phenomenon. It relies on cognitive faculties such as memories and feeling capacity. Thus, a mandatory question is whether moral knowledge could be crucial for the development of some kind of moral behavior. And I think a good reason to embrace the coevolution hypothesis is that by having both alectic and deontic modalities, it allows to modally express the moral trait of impulse control in a consistent way we might not be able to get by working with a single modality, whether alectic or deontic. So a moral agent A knows that she could do something and it's possible for her to do P, but she also knows that she should not do it, and it's forbidden for her to do P. Impulse control is a core feature in many ethical theories in moral philosophy. For example, Aristotle's view on virtue and Christian view on deadly sins. Furthermore, empirical research suggests that primates exhibit impulse control. For example, a chimpanzee alpha male may decide not to react to younger males' provocation or jokes, knowing when to choose his battles. How we come to know what we can do may be explained by Vedder's agency accounts in the phenomenological experience of our agency and reality is a good starting point, and by the counterfactual-based account, we may also have the resources to deliver new state of affairs based on what we might know from previous cases. And how we come to know what we ought to do is an intriguing question both for philosophers and biologists. And the evolutionary studies of morality have proliferated ever since the development of sociobiology in the 1960s, and many accounts are available. The continuity of social instincts, we share moral capacity with other animals, especially primates. The difference is only of degree, but not in nature. Kin selection, we might be disposed to help others that are relatives to us, or at least genetically close. Reciprocal altruism, good deeds toward others, are corresponded by good deeds in return. So reciprocity is usually a good robust strategy. And cold blood morality. The warm morality we learn within our family and close friends set the basis for the moral behavior toward strange, distant people to whom we owe respect. Thus, we have a wide range of theories to account both for modal and moral knowledge, and they might work together sometimes. Now, not all moral behavior is explained by biological facts. Controlled environments are also important, and some biologists and philosophers often discuss the gene-culture coevolution. Some obligations and permissions are learned through a system of punishment and rewards. For example, primates such as macaques and chimpanzees learn their places in social hierarchy and how to control sexual impulses through punishment. And this might offer a good case for what it happens with physical necessity or apparent physical necessity if Gnostic's skepticism is granted. If you fail to obey physical necessity, you will get punished not by another individual, but by nature. And painful experiences often lend to moral judgments on impossibility. I have heard many times that it is impossible for a soccer team A to win the championship just because they have never gotten into the semifinals. At the beginning of the season, all the teams have the possibility to win the championship. So it may be more accurate to say that it is highly unlikely that Team A will win the championship. Nonetheless, given given what we have thought about the origin of model ideas, we might understand whence it's impossible came from. And now, the evolutionary studies of metaethics also provide a fertile ground for model epistemology. Sean treats Darwinian dilemma as whether moral realism is compatible with the fact that natural selection has deeply influenced the content of our moral judgments. And Street holds that they are not compatible, so moral anti-realism is a better option. Amy Thomason has taken Gnostic scepticism as the model analog to Street's Darwinian dilemma. In both fields, the mind-independent facts become problematic under an evolutionary lens. Here's not the place to say whether any of these arguments is correct, but the moral analogy offers us a new perspective on moral epistemology. Michael Ruse believed that being a Darwinian in ethics is almost a commitment to moral skepticism. However, following David Hume, Ruse had suggested that even if there are no moral mind-independent truths, we have developed the capacity to objectify our moral duties to foster comparison. If the analogy is allowed, we might say that the same may happen for moral knowledge. Even if there are no metaphysical truths, as Gnostics argue, we might have the capacity to objectify metaphysical necessities to achieve laws and stability in the face of an anarchic and chaotic universe. Chakrabarty and Nicolai point out that in the classical Indian philosophy, the discussion of counterfactual focused less on how they are true than on how they are used. And perhaps it is a time for us to do the same with moral knowledge. What I have sketched here is an overview of evolutionary insights on moral epistemology and my own proposal of the modal moral coevolution hypothesis. Certainly, a long way lies ahead of us, and the challenges to come will require an open mind and the courage to explore different areas of knowledge. However, we might gain some new insights into how our model and moral beliefs have co-evolved, and that will be all. Thank you for your attention. Well, actually, the brain structure has been more studied for the case of moral necessity. Indeed, when we make moral judgments, for example, that is something bad, the regions that get activated in the brain are those associated with the feeling of, I don't know how to translate, asco? Repulse. So every time we feel something is bad, that you should not do it, we feel repulse. And maybe the same happens when we have some kind of moral beliefs. Maybe there are unpleasant emotions underlying. So yes, I think this is a good approach for it actually embodies model thinking, and it's not so rational as many would like to believe.
Thanks for the presentation. Not understanding at all, but I'm curious because at least what I'm understanding of the situation is that you are dealing with a semantic understanding of I'm not very sure how useful, for example, for some external elements
and be included in analytical people, especially considering that you are also saying that this cannot apply to human beings for the time. I'm not very sure how you bring this idea of language on the one side, and you, for example, in Norway, considering the difference in the partner of human beings.
Okay. No, thank you for your question. Actually, it is kind of interesting because an idea that it's constant in evolutionary epistemology is that we must have a continuous with other abilities we share with other animals. So yes, maybe modality and morality do happen in language, but we have other mechanisms that allow us to have these kinds of judgments. Indeed, for example, Amy Thomason does accept that his proposal is limited to articulated language. However, that does not mean that it may be extended to non-linguistic expressions on modal thoughts and moral thoughts, and we may have some access by what we know about the evolution of morality.
Question?
So, okay. So, thank you. Sorry for that. Well, this presentation examines the history of evolutionary thought through the visual metaphors that have been used to represent nature and more specifically human evolution. My main argument is that graphical representations or visual representations are not merely illustrative devices, rather they actively participate in the conceptual construction of scientific theories and in the way scientists imagine biological diversity, ancestry, and the place of humans within nature. In this sense, the history of evolutionary theory can also be understood as a history of changing visual and epistemological models. I will focus on three major moments in this process. First, the pre-Darwinian conception known as the Great Chain of Being, which represented nature as a fixed hierarchical order. Second, the Darwinian transformation of this worldview through the metaphor of the tree of life and the concepts of common ancestry and descent with modification. And finally, contemporary paleoanthropological models associated with the idea of the braided stream, which emerged from recent evidence in molecular biology and paleogenomics, showing processes of hybridization and gene flow among human lineages, such as Homo sapiens, Homo neanderthalensis, and Denisovans. I will share with you some final remarks. And what I want to suggest is that these visual metaphors reflect profound transformations in ontology, explanatory models, and scientific understandings of human evolution. So, before Darwin, one of the most influential frameworks for understanding nature was the Great Chain of Being, which is an important metaphor for Western thinking, especially in what has to do with the order of nature. This conception has its roots in classical antiquity and medieval philosophy, which imagined the universe as a continuous and hierarchical order in which every entity occupied a fixed and predetermined place. Nature was understood historically. Nature was not understood historically. Species were considered stable, immutable, fixed, and organized according to degrees of perfection. Within this model, that you can see these images in the slide, the human being occupied a privileged position near the top of creation, reinforcing an anthropocentric and teleological vision of the natural world. The idea of the chain of being brought into the discussion the problem of the missing link, which is also an important concept, which right now we are not using anymore, but in the popular thinking, the idea of a missing link is still a really potent idea. So this idea of the chain, of the great chain of being, can also be named as the scala naturae. And here I would want to say that this idea organized in gradual levels from minerals to human beings. And there are three main concepts that are the underpinnings of the great change of being, which is the idea of plenitude that came from the idea of Plato, and also continuity and gradation that are ideas that Aristotle proposed as this fixed and immanent nature. So, one of the more important works on this concept of the great change of being is this work of Franco-Mexican doctor, which is called The Great Change of Being, and that's the history of an idea, and that I recommend a lot. The next idea, or the consequence of this notion of the great change of being, was the famous image of the March of Progress, which expresses a linear and progressive reinterpretation of human evolution. It metaphorically represents the great change of being, specifically in the context of human evolution. And as you can see, this idea is really straightforward, no? And what is trying to represent is a linear perspective of human evolution. Right now, we know this is not the way it has proceeded. This also, what I want to say is that this idea has had a lot of influence in the popular way of thinking. And if we ask people what does evolution is, many of them think something like this, no? Because this is a really straightforward idea, an easy idea to understand. And also because there are a lot of another images that clearly represent this failed idea, but that still is present in the popular thinking. There are a lot of images like this that you can find in the internet. So in sum, for this first stage of the evolutionary thinking on human evolution, I would say that in sum, the great chain of being constituted one of the most influential conceptual structures in the Western intellectual tradition. Its legacy persisted even after the emergence of Darwinism and evolutionism, and still, right now, there are, I repeat, there is people who still have this idea in their head. Many modern ideas about biological progress and social hierarchy retain elements derived from this tradition. Okay, so I will go through the second stage, which is Darwinism and modern synthesis and what they think on human evolution. So the publication of Darwin's on the origin of species in 1859 introduced radical conceptual transformation. The metaphor of the chain or scale was progressively replaced by the image of the branching tree, which you can see in the slide. And this is one of the most famous images of the Darwinian thinking, which was found in one of the notebooks of Darwin. And what it reflects is something like, I think that is, right? So what can we see there is the idea of a tree of life, which in some years will become the idea of the phylogenetic tree. With Darwin, biological diversity ceased to be understood as a static hierarchy and became instead a historical process of descent with modification. The idea of common ancestry fundamentally changed the representation of life itself. I come back here and you can see the number 1, which precisely means the common ancestor, right? And this is a very, very important and potent idea of evolutionary thinking. This famous sketch by Darwin, accompanied by the words "I think," is perhaps one of the most important conceptual images in the history of biology because it visually condenses the transition from hierarchy to genealogy. Another important representative of this way of thinking was Ernest Haeckel, who proposed that Southeast Asia should be considered as the right place to search for the origin of man, and who also proposed this tree of life as a metaphor of how diversity becoming to be. Okay, so as evolutionary theory developed during the late 19th and 20th centuries, the tree metaphor became increasingly central to biological thought. Phylogenetic trees did not simply classify organisms. They reorganized biological knowledge around the principle of genealogical relationships and common descent. In this new framework, classification was no longer based on fixed hierarchies or degrees of perfection. Instead, it became an attempt to reconstruct evolutionary history itself. This transformation had profound implications for anthropology and for the scientific understanding of human origins. Human beings were no longer conceived as separate from nature or as the final goal of creation. Rather, humans became one branch within a much broader evolutionary history shared with other primates. This shift can be clearly observed in the transition from traditional classifications of hominoids to modern phylogenetic classifications. In the slide, you can see in upper place the traditional hominoid classification based on similarities, morphological similarities, while the second, or the one which is at your right hand, the modern hominoid classification is based on molecular biology studies. So this is how also in the sense of cladistic organization has changed also in a visual perspective. Okay. Sorry. So just to close this second stage, earlier taxonomic systems tended to isolate Homo from the other great apes, preserving a certain anthropocentric logic inherited from pre-evolutionary thought. Modern evolutionary classifications, however, emphasize evolutionary relatedness and common ancestry, integrating humans within the broader hominoid lineage. At the same time, paleanthropology began to abandon linear representations of human evolution. The famous March of Progress image, despite its popularity, presents a misleading interpretation of evolution as a linear progression toward modern humans. And now I will proceed to the third stage of this shifting epistemology towards evolutionary or human evolutionary thinking. And I will bring into the stage the idea or the concept of braided stream, which is maybe the most recent or the most, the most recent metaphor used to represent visually the idea of human evolution. So contemporary paleanthropology instead reveals a much more complex picture. In contrast with modern synthesis and of course with pre-Darwinism thinking, contemporary paleanthropology instead reveals a much more complex picture characterized by coexistence, diversification, extinction, and branching evolutionary processes. Different hominin species coexisted for long periods of time, and human evolution increasingly came to be represented as a branching and dynamic process rather than a unilinear sequence. This is especially evident in models emphasizing African origins and the dispersal of multiple hominin populations across Eurasia. Sorry for this, but I will like to show you these images to emphasize how African origins and the dispersal of multiple hominin populations across Eurasia are the leading models that represent human evolution. The classical tree model began to show certain limitations when confronted with the evidence of hybridization and gene flow among distinct human lineages. We now know that Homo sapiens interbred with Neanderthals and Denisovans, producing patterns of genetic exchange that cannot be fully represented by strictly branching trees. This is the context in which the metaphor of the braided stream emerged, and I will show you the idea of a braided stream. Unlike a tree, where branches separate permanently, a braided stream consists of channels that divide, reconnect, and exchange flow over time. And this is precisely the idea that we are advancing in human evolution, because the evidence shows us that humans, Homo sapiens, Homo neanderthalensis, and another population of humans that is called Denisovans have interbred during a long period of time, not so much far away, no? And this is really, really, really interesting. This model or this visual representation is more accurate in the way of representing these kind of processes of branching, reconnecting, and so on and so forth. Another possibility for this kind of visual representation is the one that you can see also in the slide. And the metaphor, this metaphor comes from fluvial geomorphology, but it has become increasingly useful for representing the reticulated nature of human evolution. Reticular evolution is another very important concept in this extended evolutionary synthesis. And for the case of human evolution, the skin of this giraffe, the patterns in the skin of the giraffe, clearly represent this idea. In this framework, human evolution is understood not only in terms of divergence, but also in terms of interaction, admixture, and reconnection among populations. What is particularly interesting from a historical and epistemological perspective is that each of these visual metaphors, the chain, the tree, and the braided stream, corresponds to a different way of conceptualizing nature, biological diversity, and human evolution, and humanity itself. I will finish with some remarks in which the great change of being represented order, hierarchy, and fixity, while the Darwinian tree or the phylogenetic tree or the tree of life, whichever you want to say, represented historical descent, divergence, and common ancestry. It's a clear rupture between the pre-Darwinian thinking and the Darwinian and modern synthesis perspective. And finally, the braided stream represents fluidity, reticulation, hybridization, and gene flow, which in a sense is what we are seeing, what we are discovering in the fossil record and in the paleoanthropological record in terms of this mixing between admixture between the different species I have just mentioned. In this sense, the history of evolutionary theory can also be interpreted as a history of changing visual models through which scientists have imagined and represented life and human evolution. And this visual representation and representations and metaphors, I think that really clearly represents these changing ideas toward the notion of human evolution. Thank you very much. Of course, I think that evolutionary developmental biology is part of this third stage, which I associated with the extended evolutionary synthesis. And as you know, evolutionary developmental biology, Evo, is precisely one of the main pillars of this extended evolutionary theory. I think also that the models used and the visual representations used in the evolutionary developmental biology are part of this more complex idea of evolution, in which you have some traits with some very fast evolution, no, and some other traits that are pretty conservative. So modularity. So these kind of interrelationships are better reflected in the evolutionary extended synthesis and with these kind of gradient stream models. Yeah? Yeah. Well, it's a very good question because the great change of being was focused on living beings, but the idea of living beings in the antiquity were different from the ones we have right now. So if you look at this image, well, you cannot recognize it from there. Not even that one. But what you have here is the upper graph. Then you have minerals. Then, so the idea of the Greeks was that they can order the whole world, not just the things, but also the non-organic elements. So you have them in a progressive order. You have minerals, stones, trees, plants, terrestrial animals, women, man, yes, the yeah, and then God, right? So this idea had a lot of different kinds of ways of representing nature, and the concept of the creation thing is a notion that lasted maybe 15 no? So it changed in the different states in Turkey.
And the one about the
The example of Denisova is something that we have to put our eye on, because as you might know, or maybe you were not aware, or you are not aware that there is Homo sapiens, Homo neanderthalensis, and Denisovans. So let me explain this idea. Homo sapiens and Homo neanderthalensis are taxonomic species, while Denisovans are genetic species. There is no fossil which is associated directly with them. So there are no Homo Denisovans. You see, this is something that can help us to make some other kind of clusters, but in different levels of organization. No? So I think my answer would be yes, but you might be really careful to see in which level of the hierarchy you can bring this idea or not. Right? Of course, genetics genomics recently have become a really powerful tool for showing maybe some ideas that in the past were difficult to show. But I think there is maybe it's leading what genetics and genomics can tell us. No? There is a lot of, genetics, they say that genetics will give us the answers that anthropology and archaeology never gave us. No? So there is a really important segment in what genetics and genomics can bring. What I can tell you, Jorge, is that in the three stages I have shown, at least in the second and the third, there are morphological evidence, genetic and even behavioral. No? So, for instance, Great Danes behavior or monkey, so on. No? So it's I would say it's a multi-factorial perspective which tries to merge morphometrics, genetics, and of course philosophy. What I would say is that extended evolutionary disease, in some sense, consumes the modern disease. No, so it's extended evolutionary disease. But I must say that it's not the same with the great change of being. Because the great change of being has these ideas, but failed ideas like humans are the top of things, right? And what modern scientific and evolutionary, extended evolutionary are trying to say is that it is a wrong idea and humans are just another species which is part of this whole phenomenon. So I don't know if I answered you. Yes, yes. No, yeah. Okay.